Mikrotik EoIP, Ethernet over IP, is a tunneling protocol used to connect two networks over the Internet or any IP network. It encapsulates Ethernet frames into IP packets, effectively allowing Ethernet traffic to be transported over an IP-based network. This is useful for bridging two networks as if they were connected by a direct Ethernet cable, even if they are physically separated by a considerable distance. Pros: Layer 2 connectivity. EoIP provides a way to extend Layer 2 networks over Layer 3 infrastructure, which can be useful for applications requiring Ethernet bridging, such as extending VLANs across sites. Integration with Mikrotik devices. EoIP is integrated into Mikrotik's router OS, making it easy to set up and manage on Mikrotik devices. Simple configuration. EoIP tunnels are relatively easy to set up compared to other tunneling protocols, with straightforward configuration on Mikrotik routers. Flexible usage. EoIP can be used for various purposes, such as creating site-to-site VPNs, connecting remote offices, or even linking different network segments within a large network. VLAN support. EoIP can carry VLAN tagged traffic, allowing for the extension of VLANs across different sites. Lack of encryption. EoIP itself does not provide encryption, making the traffic vulnerable to interception if transmitted over untrusted networks. Additional measures, such as IPsec, are required for secure communication. Overhead. EoIP adds overhead to the network traffic because it encapsulates Ethernet frames into IP packets. This can reduce the effective throughput and increase latency. Not compatible with non-Mikrotik devices. EoIP is a proprietary protocol specific to Mikrotik. It may not be directly compatible with devices from other vendors, limiting interoperability. Performance limitations. The performance of EoIP tunnels can be affected by the underlying network's quality and the processing power of the Mikrotik devices. High throughput or low latency requirements may necessitate more powerful hardware. MTU issues. Managing maximum transmission unit (MTU) sizes can be challenging with EoIP, especially when dealing with mixed network environments. Incorrect MTU settings can lead to fragmentation or dropped packets. We can set up the EoIP tunnel in a similar way to the IP tunnel. Please review that video first if you haven't yet. For this setup, we'll focus specifically on the bridging component. In this lab, we'll set up a DHCP server and use an EoIP tunnel to broadcast its service to Mike's Mikrotik router. This configuration will enable Mike's PC to obtain an IP address from the Office server. We'll confirm the setup by testing the connection and pinging the Office server's IP address. Let's access the Office Mikrotik and Mike's Mikrotik routers. Here are the WAN IP addresses for both the Office and Mike's routers. Let's ping the Office IP from Mike's Mikrotik to check for connectivity. Let's configure the IP address for the DHCP server. Let's configure the DHCP server and make sure to note which Ethernet interface you assign the IP address to. Let's go to the lab, click on the virtual PC, and let the DHCP client request an IP address from the DHCP server. The IP address of the Office PC server is 192.168.1.254. To configure an EoIP tunnel for the Office, set the MTU to 1500 to prevent packet fragmentation. Use the Office WAN IP as the local address and Mike's Mikrotik WAN IP as the remote address. Make sure to set the EoIP tunnel's unique identifier, ensuring it matches the identifier on the other end of the tunnel. On Mike's Mikrotik, ensure that the local address is set to Mike's EoIP and the remote address is set to the office EoIP. Our EoIP tunnel appears to be up and running. Next, we will configure the Mikrotik routers at both the office and Mike's to bridge the EoIP tunnel. This setup will allow Mike's PC to obtain an IP address from the DHCP server. Also, make sure to include the Ethernet port connected to your PC within the EoIP tunnel configuration. Just need to change Ethernet 2 on the DHCP server to bridge, as Ethernet 2 is already part of the bridge. Okay, let's check Mike's two PCs to see if it is now receiving an IP address from the Office DHCP server. Let's ping the office server IP from Mike's PC to check if we have a connection.